Hi, I'm Basit. I built BOF-TOOL, which is the Buffer-Overflow tool. It is a modular batch toolkit that automates the common steps in Buffer-Overflow exploit development. In this video, I'll explain Buffer-Overflows briefly, walk through the BOF-TOOL's design, and demo a full exploit chain on a local vulnerable machine. Let's go. Before I dive into this, I'll be giving a brief explanation of the buffer overflow exploits. A buffer overflow happens when more data is written into a stack buffer than the program expects. If you overflow up to the saved return address, known as the EIP, extended instruction pointer, you can overwrite it and redirect execution. The typical workflow: find where the app crashes, which is known as pausing, find the exact offset to the EIP, which is the return address, determine which bytes are saved for shellcode, simply meaning finding the bad characters, and also find the jump ESP, which is the jump execution to our shellcode, and then build and deliver the payload. Here is my GitHub page. And over here is where the tool is located. So basically, BOF-TOOL is organized as a dashboard and small scripts. Here is the dashboard, and here are the scripts. Dashboard.sh launches the menu. The scripts are exploit.sh, the Fuzz, which is the Fuzz.sh, the build underscore payload, which builds the payload and automates foothold, the finding of the bad characters, the finding of the jump execution, and lastly, the finding of the offsets. I keep each stage small and focused. Fuzz.sh increments payload length and tests the service. Here is a view of it. Find offset.sh uses Metasploit pattern tools and GDB to extract the return address, which is the EIP, extended instruction pointer. The Badchars.sh builds a bad character pattern and then reads the stack dump, while the find underscore JMP underscore ESH uses Roper to find the jump execution address. And lastly, the build underscore payload calls the msfvenom to generate shellcode and builds the payload. After that, it then automates the whole photo process. The dashboard basically stitches these modules together with a simple menu. I'll demo this against a vulnerable machine hosted on the OneUp platform. I'll be doing this utilizing two machines. Here is a view of the OneUp platform. And these machines are namely Fawkes, which is our reporter series. The second machine will be Great Balogun. This is it here. So BrainPower hosts a vulnerable Windows binary, which is our part to the buffer overflow exploit, and the Fawkes hosts a vulnerable Linux binary, which is our part to the buffer overflow exploit. So to get access to the source code, you can go over to my GitHub site and ensure to clone the directory. With this, you'll be able to have access to the source code and you'll be able to run it on your own personal virtual machine, which I'll be doing here. So I'd say we should start with the Fawkes vulnerable machine as it contains a Linux binary. So here is it. This is a review of the one-up Fawkes vulnerable machine. And to get the IP address of this particular machine, since they are also on the same network, I can just use nmap. This should be their address, which you can confirm. So with prior exploits of this machine, the vulnerable binary is being hosted on the port 9898, which you can test for here. So there you can see. So this is what we'll be exploiting. So the sole aim is to use my tool to gain foothold to this particular machine. To get my tool to run, we'll just do ls. So you can see here we are in the directory of the tool, which you can check the P, you can see right the BOF-TOOL. So all you need to do is just run this dashboard.sh script. Do that using bash command. So now since it is a Linux elf binary, you can go ahead and run the full chain, which automates the whole process rather than doing it one by one. So the option will be 6. So the full path of the target binary will be. So this is going to be the target IP address, which is 720.20.10.4. The ports. So it is a remote service. So go ahead and choose remote. So what it's doing here first is pausing for the breaking point. So you can see it's crashed at 200 bytes. So what it's going to do next is going to find the offset. And here you can see it tells you the offset is 112. So next is getting the JMP address, which is the jump execution. Here you can see the JMP address in the little endian format. So now what we're doing next is we are building the shellcode. So here he asks for the target OS. It is a Linux machine. So click on that, type in Linux, localhost. So basically the attacker's IP address. The port I want to listen on. So basically it's going to give a reversion back to this particular port. The offset value can be seen here, 112. The JMP address can be seen here. Just go ahead and copy this. So it defaults to 16, but I can go ahead and just type in 16 if I want to. Enter the bad characters. As you can see here, it tells you there are no bad characters. So now you can go ahead and continue. So would you like to send the payload to gain foothold? Yes. So now you can see we've been able to gain foothold on the machine. You can confirm this by using the who am I to see you're logging us. And you can see you're logged in as a user Ari. With this, you've been able to gain foothold to this particular machine. You can also check the IP address to be sure. So now with this, we can go ahead and move on to the next one. So we can quit this. So it prompts you, do you want to return to the main menu? Go ahead and click yes. So now we can go ahead and use it to solve the next machine. which is going to be the brain pan one. And this one utilizes the Windows exe file. So I can't run the full chain exploit on it. I need to do it one by one. So here is the brain pan one. The machine is up and running. So we can come over here. We'll go ahead and get the IP address of this particular machine too. I believe it should be this. Now we can confirm this. So with prior exploits of this machine, the vulnerable binaries are still on the ports 9999. So we can confirm this. So here you can see. So now that we know this, you can go ahead and continue with this. So the first option is for us to force the target, which will select the option one. It's a remote service. So the binary is located in the downloads directory. There was a mistake on my part. It was meant to input the IP address here, not the binary. So you can just go ahead and redo this. So let's clear this and reload it. Option one, the remote service, target IP address, port. Now we know it crashes at 600 bytes. So the next thing is to find the offset to get the exact breaking point. But this generally works with just the line of stuff as I used the GDB in this particular code. So in the future versions, we utilize other debuggers for the Windows file. But for now, the offset is 524. So we can go ahead and just skip to the find GMP. So skip to the option 4. So the full path to the target binary. So that was slash oil slash Kali downloads. Now we've been able to get the JMP address. So you can go ahead and go straight to the building of the payload and then automate full toad after. So the next thing, so I made a mistake earlier. I was meant to save the JMP address, which I didn't. So let's go ahead and run this. So here it is. Just go ahead and copy this. The next option will be the option 5. First thing we have to do is enter the target operating system, which is a Linux operating system. The local host, which is the attacker's IP address. The port in which you want to get a reverse shell. So that will be the port 1010. The offset value 524. The JPSP value we copied earlier, we can go ahead and paste that here. The low pitch line, we can just enter the value of 16. And if you do not enter anything, it defaults to 16 itself. The bad characters we have none, so we can just default to the X00. So with this, the payload has been set, shellcode has also been set, so you can go ahead and set the payload to gain tool. So it's a remote service. So we enter the target IP address. So the target port is 4999. And now with this, we've been able to get tool. We can confirm the user we are logged in as using the go by command. And here we are saying we've seen that we are logged in as the user Fawkes. We can go to the home directory. So we confirm the users that are available there. So now you can see these are all the users available on this machine. And that will be all for this particular video. Thank you.